Welcome back. We continue with our study, and our objective is still to solve linear equations in one unknown. Success criteria is to be able to solve them using algebra. Now, for linear equations of the form ax plus b equals c, we will solve or see a few examples, and then I'll give you some problems to do, and for selected problems I'll show the solution at a later date. Now we've got here the format y equals ax. Okay, so for linear equation of the form ax plus b equals c, the alternative format is y equals mx plus c, which you would have seen before, and both of them are equivalent. So here we'll use that format ax plus b equals c, whether you use y equal mx plus c or ax plus b equals c, it's very similar. Let's look at this first example. Solve the equation 3x plus 4 equals 16, and we'll solve it for x. Alright, now all of those problems, we follow the same steps. First, we need to get rid of the constants from the left hand side. We want to end up with x. So first we get rid of the 4, we move it to the other end, we end up with 3x equals a constant, then we get rid of the number multiplying the x, and we end up with x equals. So this is the ultimate goal, is to get x equals. Okay, so the steps are, you look at where x is, you put all the x's or whatever variable letter you're using on one hand, one side like the left hand side, and the rest on the other hand side. And then if there's anything multiplying the x, whether it's a number multiplying or a fraction or whatever it is, then you get rid of it. And what we use is the inverse. So for example here, we've got the plus 4. So we want to get rid of the plus 4. The opposite of plus 4 or the inverse is negative 4. So what we do, we add negative 4 to the left hand side and to the right hand side. So they cancel out and you're left with 3x equals 16 minus 4 is 12. So 3x equals 12. We want to get rid of the 3. So this is 3 times x. Alright. So the opposite of multiplication is division. So we divide by 3 both sides. And it's very important to realize that you need to do it on both sides. Alright. So 3x equals 12. If we divide both sides by 3, that's gone, and that's equals 4. So you end up with x equals 4 as your final answer. Now, the steps are, you go ahead and eliminate everything like what we said. We put the constants on one side, the variable on the other side, and you keep manipulating until you get our variable equals, like here. Then last step would be to verify that you didn't make a mistake, and that would be by substituting the value in the left hand side and then verify that indeed equals the right hand side. And if we did have variable on the right hand side as well, we substitute in the left hand side, we get a value. We substitute in the right hand side, we get a value. We make sure that they are equal. And in this case, on the left hand side, you substitute x with 4, 3 times 4 is 12, plus 4 equals 16, and this is indeed the right hand side equals 16, so this is our solution. Let's continue. In the other example, example number 2, we've got 4x plus 3 equals 3x minus 5. So this is equation with unknown on both sides. So you do exactly the same steps, but what we need to do here is to put the x's on one side and the constant on the other side. So in order to get rid of the 3x from the right hand side, we add minus 3x, and we need to add the minus 3x on the other side as well. So 3x minus 3x, they cancel out. You're left with negative 5. 4x minus 3x, you get the x. So x plus 3 equals negative 5. We want to get rid of the plus 3. We subtract 3 from both sides. So here, the 3 minus 3 are gone. Minus 5 minus 3 is minus 8. So you end up with x equal minus 8. You substitute in the left-hand side. Here we've got x on both sides in the original. So you substitute x left-hand side and right-hand side. You substitute in the left-hand side, you get minus 29. Right-hand side, you also get minus 29. Same number, so this is indeed a solution. Now, when we go to example 3, equations that have brackets in them, the very first step you need to do is, well, you can, in general, you have to expand, and don't forget that by expanding, remember your board math, you need to multiply by everything that's inside. So you need to multiply the 3 with the 2x and the 3 with the plus 5. Now, if we do that, you get 6x plus 15 equals 27. Then same thing, we need to get rid of 15. We subtract 15 from both sides, we get 6x equals 12. We want to get rid of the 6, we divide by 6 both sides, so you get x equal 2. Now, one thing we can do alternatively is, if you notice from the start, is that 27 is divisible by 3. 27 divided by 3 is 9. Okay, so we could have also changed the equation from the start to be 2x plus 5 equals 9 and solve it, which will make it same format as what we just solved before. Then this one, what you have is you subtract 5 from both sides, so it becomes 2x equals 4. You divide by 2, it becomes x equals 2. So you get the same solution. Okay, and that would have been much easier. So first step is actually try to find if you can simplify before you expand. If you can, you do, and makes it much simpler, and you continue. If you can't, then you do what they've done here. And the final step would be to check. So you substitute the value of found x, which is 2. You substitute it, so it becomes 3 times 2 times 2 plus 5. 2 times 2 is 4, plus 5 is 9, times 3 is 27. And the right hand side is indeed 27. So this is indeed our solution. Fourth example is an equation containing fractions. So here we've got 1 over 5 and 1 over 3 as the fractions. Now, same principle, we need to get rid of the constant and what's multiplying the x's. So we've got two ways. One way is to get common denominators, and then you continue cross multiply, you get equations that doesn't have any denominators, so we eliminated the fractions. Alternatively, and probably some people will see that as easier, is to try to multiply by a number both sides that will eliminate the denominators everywhere, and that would be the lowest common denominator. So if you look here, 5 times 3 is 15. If you multiply everything by 15, so don't forget the way you do it is you place brackets so you don't make a mistake. If you multiply by 15, then 15 is multiplying the x over 5 and it's multiplying the negative 2. And on the right hand side, multiplying x over 3. If we do this, then 15 over 5 is 3. So instead of 1 over 5, now we've got a 3. So, and then instead of 1 over 3, 15 divided by 3 is 5. So we end up with an equation very similar to what we had before. Okay, so now we only need to get rid of the constant, put them on one end, and terms with x on the other end. Then you divide with what's left, multiplying the x, and you get your solution. Now, just note here we divide by negative 2. Negative 2 and negative 2 cancel out. When you type 30 over negative 2, you don't leave it as 30 divided by negative 2. This is negative 30 divided by 2, which is negative 15. Alright, so in mathematics, mathematical expressions, you make sure you put the negative at the top. In some cases, you know, if this was not if this was, let's say, 7, a number you cannot divide by, and you wanted to leave it as 30 over 7 or 30 over negative 7, you don't leave it as 30 over negative 7 or you'll lose marks. You put it as negative 30 over 7. That's the proper mathematical notation. Now, final step, we got x equal negative 15 as our solution. Final step is to check left hand side and right hand side to make sure that this is solution, and this is verified by getting the number and verify it's the same number. So substituting, we get negative 5 on the left hand side, and right hand side also we get negative 5. It is the same. This is indeed our solution. Now, example 5 is also an extension to this one. So this is still dealing with denominators, with fractions. So in this case, same thing. Lowest denominator is 2 times 3 is 6. So we multiply everything by 6. So don't make a mistake of multiplying just one or the other. We're multiplying both sides. Okay, we are multiplying both sides. So you put a bracket so you don't make mistakes, and you say we're multiplying by 6 and we're multiplying by 6. That's why it's this times that and also times that equal this. Then the 6 divided by 2 is 3, and 6 divided by 3 is 2, and 5 times 6 is 30, so you end up with something that doesn't have denominators anymore, and you simplify and put the constant on one end and terms x on the other end. You divide by what's left here, it's minus 1, so you divide by minus 1 both sides, and you get x equals negative 31. You check, you substitute, you get a number which is here 5, which is the same as what's on the other hand. So left hand side equals right hand side for that value. So indeed this is our solution, and this is exactly what we've been talking about. You've seen that it's just an extension. There are very similar principles. You just manipulate to get the constant on one side and the variable on the other side till you get the variable on its own with nothing multiplying except a 1. So you get, if it is called x, x equals, and then you substitute left hand side, right hand side with that value. If the right hand side does not have except constant, then you just substitute left hand side to get that value, make sure it is equal right hand side. If the variable originally existed on both sides, so you substitute left hand side with the x value, right hand side the x value, and make sure you get the same value. Okay, now the only extension for this that we're going to cover is when you have the fraction given to you as odd point. So let's say instead of giving you 1.8 divided by 3, it's 0.6, so they give you 0.6. We'll do that later, just after solving the same problem using the calculator. So you're going to see an example of solving it using the calculator, and I'm also going to show you when we use the emulator tips and pitfalls. So we put on purpose some mistakes, okay, so you can see what not to do, and also we'll show you how to properly do it. So there are some common mistakes and pitfalls. We'll
As you've
try to
seen,
avoid them.
this section 1 in a summary, an equation is solved by finding the value of values of the variable that would make the statement true. Linear equation, it has to have only first power, so the maximum power is 1. There are often several different ways to solve it, several linear equations, and the following steps provide some suggestions. Expand brackets, and if the equation involves fractions, multiply through by the lowest common denominator of the terms, which is obtained by multiplying those terms. And as you've seen, even if it is on both sides of the equality. Group all of the terms containing a variable on one side of the equation and that term that don't have it on the other side. Let's go to the emulator. And as you see here, I was actually trying various things with this. Um, this is the menu button. Okay, if you press on it, it doesn't bring anything. On the actual calculator, it will print it for, as just mentioned before, it will bring for you then the options. Now, with this one, in order to get the options, you get them from here. So this is like pressing the menu. All right. So when it says press menu, press on the tools. This is your menu. Okay. Then on it, you've got this option, which is algebra. So when it says menu, then go to algebra, click on it, then you go to solve. If you click on solve, it will insert the solve for you. Then you type in it what you want. Now, remember, what do we want? Let's go back. We want x minus 3 divided by 2 to start with. Okay, x minus 3 divided by 2. Now, in order to get to write it in this format, what you do is you go to the symbols here. You have two ways. This is one of them. I can show you the rest later on, but this is the quickest way. You go here, and the buttons on the actual calculator also do work if you want to go and use them. But go here, that symbol we want, double click on it to get that. So then we say, all right, we want it here. This is what we want, x minus 3 over 2. So what we type, now you can use your keyboard or you can use this. You can say x minus 3 divided by 2. So you just fill in that thing. Now click here, prepare for the next one. X minus 3 divided by 2 and minus, then it's 2x minus 4 over 3. So we can put the minus sign and again and 2x minus 3 divided by 4. Now here it doesn't really matter whether you put the multiplication or not, because it will change it to 2 times x. And you see, it actually, here this dot is a symbol that it realizes that it is multiplication. But in other types where you actually don't have numbers, but they give you, let's say, x and a and b and c, and you need to find x in terms of a, b, and c, and you put them and you've got like ax or abx, you have to multiply a times b times x. So you need then to put the multiplication sign. Alright, so you have then to use this. Here it doesn't matter, but it could be good practice to always, when instead of put 2x, put 2 times x. But and the last thing is, now if I now hit enter, I will get an error. Why? Because I did not tell it which variable I'm looking for. So the last step is to put comma and put the variable. So you hit enter and hit it on the keyboard over here. Right. Notice, what did we also miss? What is it going to solve? We didn't tell it what it's equals to. Let's go back. It's equals to 5. So we put the first part, but which point we're looking for? We're looking for the point when the difference of these two is actually equals 5. So there's nothing for it to solve unless we put that in. Okay, so leave that there, and then we can copy and paste. All right, and then modify this one to says equals 5. You can get it from here, equal 5. Okay, now hit enter. This isn't right. Tells you there's no solution. Let's see, if I write the thing x minus 3 over 2 minus 2x minus 4 over 3. 2x minus 4 over 3. So you see here, if you do
Now,
right wing
I guess
and
you don't want me to show you how
you
to do
don't
it.
write the right, you copy it exactly like this. Okay, we need to copy it again. Minus 4 over 3. Okay, so that's the other thing to be careful of. And enter. Now it gives you the solution.
The cool crab.
Okay, so let's make sure this is the same equation. X minus 3 over 2, x minus 3 over 2, minus 2x minus 4 over 3, and x equal indeed negative 31, the same as what we got. So be very careful. As you've seen firsthand, if you change the value, then you are solving different questions. Also, if we have written even, let's copy it again. Even if you've written the whole thing, but you don't tell it what variable it is and you hit enter,
This isn't right!
then again to few arguments. It will not solve it for you. Because it's asking you, okay, what do you want me to solve? What is the variable? So you need to tell it the variable is x. Then when you hit enter, it will solve it for you. Alright?
The cool crab.
So let's just quickly go through it again. If you don't try the full equation, so you missed put in what it's equals to, then how can it solve it? It's now infinite point. You're not telling it which point we're solving, what's the condition for the difference between those two. So then you put it. If when you're copying the formula, you have mistakenly put the numbers here. So our real equation is 2x minus 4 over 3. Now if you write something different, in this particular case, you know that you made a mistake because it's telling you there's no solution. You just happen to have picked something that has no solution. But what happened if actually this did have a solution? Then you probably will not notice the mistake. You get the solution, you say, oh yeah, I got it, you put it, it's wrong. So it's very important, as you've seen, to make sure that you got that in front of you. And one way you can do it is to split the screen into two and have the equation in front of you, or to actually copy and paste the equation. Okay. Now, once you put the equation, the right equation in place, and with the equality, what's so the full equation, and you tell it that the variable is this, you hit enter, then it gives you a result. If you skip telling it which variable it is, then it will complain like I just showed you before. Okay, so let's go back. So indeed we've done this, and remember on the calculator you will say menu, you'll get what you have here under tools. So in the emulator it's like saying select tools, and from it you select algebra and solve. The same option is available on the calculator, you'll get them in the emulator, but this is one of the subtle differences. So instead of pressing menu, you will press the tools icon. Okay, and let's continue. Example 6, literal equation. This is what I was talking about, where they don't actually give you the numbers, they give you letters, but they're saying only as far as we're concerned, we're solving for x, so we take as if x is the only unknown, and that a, b, c, and d are constants, but we don't know what they are. Okay, so then it becomes very important for you to, when you insert them into the calculator, to put the multiplication. Don't put ax, put a times x, c times x, etc. Alright? Now, when we are solving something like this, ax plus b equals cx plus d, and we're solving for x, then we need to put the terms that have x in them on one side, and the terms that don't have x in them on the other side, and simplify till we get at the end x equals. Alright, so if we subtract cx from both sides, then here it will disappear, and here you will have minus cx appearing. We subtract p from both sides, this p disappears and appears there as minus p. So ax minus cx equals d minus b. Let's take x as common factor. We're left by a minus c, bracket x. Because if you go backward, it's x times a minus c times x. So this is ax minus cx equal d minus b. So to get rid of this term, we divide both sides by a minus c. So a minus c and minus c cancel out, and here it appears at a minus c at the numerator. So you've got x equal d minus p over a minus c. Alright, if we wanted to solve this with the calculator, let's do that now. Now there's also another way you can put solve. You can get from the menu, or the software is smart enough, even on the calculator, if you put solve and put bracket, it puts the other bracket, it understands that this is the actual solve function. So now you can continue, or you can just bring it from there. Remember, the tools is the menu on the calculator. So if you press it here, it doesn't do anything. This is the menu, and you can get algebra and then solve, or you just type it and then you continue. So our equation in this time, let's bring this, is actually a, and you have to put the time ax plus b equals c times x plus b. Ax plus b equals cx plus d. Let's verify that this is indeed this is our equation. Ax plus b equals cx plus d. Now we need to tell it what variable we're solving for. We have to say comma x, otherwise it will complain. So we hit enter, and indeed it gives it to you. X equal negative bracket b minus t over a minus t, which is the same as minus b plus t over a minus c, or d minus b, and you end up with x equals d minus b over a minus c as our solution. Now the difference here, there is nothing to substitute to verify that this is a solution, because they are not numbers. Okay, so that's how we solve it, and also we'll show how to do that with the calculator. And with the example of the calculators and the examples of the pitfalls, that concludes this session. And the summary for that session is that, or this section 1a summary, an equation is solved by finding the value or values of the variable that would make the statement true. Okay, so generally speaking, it's the same equation. We can get the equations represented by two lines. So let's say this is the first line, that's the second line. We are looking at the value, which is a point that belongs to both lines where they meet, that makes it true. So we're saying I want the value that will make those two equations equal, and it's only one point if there is a solution, if there are lines like that. When we found that there was no solution, the lines would have been parallel, so they don't meet. When we found that there are infinite solutions, it's the lines are over each other. It's basically the same line. So they overlap everywhere, and then you have infinite solutions. Okay. Linear equation will not be linear unless the highest power is 1, and it is the only power, as we discussed in detail in this video. And the only exception is the power of 0, which makes a variable, any variable power of 0 equals 1, then it's not a variable anymore. And there are often several different ways to solve linear equations, and we've seen many of them, and the following steps provide suggestions about how to solve them via algebra, and I also showed you how to solve them by
trial and error and graphically. But solving algebraically, you expand the brackets if there are brackets, and if the equations involve fractions, you multiply through by the lowest common denominator of the terms, and that will change them into a normal term without any denominators. Then you group all the terms contained in the variable on one side of the equations and the rest on the other side. Then if there is a term multiplying the variable, you divide both sides by it, and you end up with the variable equals. And that is the end of part 1a, and I hope you enjoyed it, and till we meet again. These are what the exercises I suggest you solve. Now, this is a revision. I'll get them to go on the screen one by one, and then you can pause the screen and solve them, and then continue. So the first one is solve each of the following equations for x. So it gives you this equation. So what I did, I just picked part of that. In the book, there's actually more. I'm just picking from each type some examples. So you do that, then the next one, solve each of the following literal equations for x. So as you see, they don't give you constants. This is like the last example. We did example 6, where instead of constants, it gives you letters. Okay, then solve the following linear equations, and it tells you here that this is very similar to example 1. So if you look at this and you don't think you know how to solve them, you can consult example 1 and then attempt to do them again. This one, the same as example 2 or similar, solve the following linear equations and gives you the variable is on both sides. Solve the following equations, and then this is introduced in the brackets. Example 3, so you need to expand first. And now this is similar to example 4, so you've got fractions, so you need to, first thing is to rid of the fractions, and which is obtained by multiplying the lowest common denominator, multiplying it on both sides. And this is similar to example 5. So again, now remember, if you can simplify before you expand, you can do that. Like here, you've got 2 multiplied, 2 multiplied, 2 multiplied, and 4 is 2 times 2. So even before you start, you can simplify by 2. So if you take 2 as common denominator here, this becomes 1 minus 1 over 5. This becomes 2 times, and the 2 is gone from here, and this becomes minus x. Then you continue. Anyway, let's go. And this is the same, similar to example 6. Well, luckily there's no third 6. Okay, solve the following literal equations for x. Again, this is instead of numbers they give you this, and you need to expand first. And then solve each of the following for c. Now they give you, instead of fractions, they give you their fraction value in decimal. So 4.6, and then we solve that, and then solve this. Now what I'll be doing after you have a chance to attempt these, I'll be not solving all of them. I'll pick the ones that are the harder ones and then give you the solution for them. Okay, so this takes us to the end of part 1a, and as you see, mathematics needs lots of practice. It actually needs practice after practice, and that's the only way of doing it. And with this, we come to the end of this session, and I bid you farewell. Till we meet again.
Smurf, 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 Smurfy Smurf, algebra, Smurf, 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 Smurfy Smurf, geometry, Smurfy Smurf, 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 Smurfy Smurf, Smurfy day.